My name is Dieter Rothenberger, and I am moderating that session. I am very pleased and honored to welcome you to this session on the launch of the report, Stop Floating, Start Swimming, which shows the interlinkages and the prospects for future action in the water sector dealing with climate change. Having worked for more than 20 years in the water sector, many of them in the interlinkage with water and climate, in Jordan and Grenada, I'm excited to see this crucial report being developed and now launched. And before we start with the presentations, just some housekeeping rules. First of all, the session will be recorded. So your participation automatically means that you grant the recording permission. If you do not want to be recorded, please leave the session. The recording will of course be made available after the session, and as always, I think we have all now grown into experts when it comes to virtual conferences and meetings. Please turn your camera off and mute yourself while you're not speaking. So let me quickly go through the agenda of that session. So we will start with Martin Karras, who sets the scene on the report. Then we will have two presentations on the content of the report, one focusing more on the physical perspective from Tobias Pilz from PIK, and then the policy perspective from Annika Kramer from Adelphi. We will then have a quick information on the launch of the report website. And afterwards, then you will get another bonus. There's another report which will be launched, and this will be presented by Gina Lovett, who will inform you about the launch of the Wetlands report. So this is basically the agenda. So without much further ado and looking at the time, I'd like to welcome Martin Karras. Martin Karras is a GIZ advisor within the water and wastewater companies for climate mitigation project WACLIM. He has been working with GIZ since 2015, has been working before that already on water and climate change topics, first at KfW and then at the Inter-American Development Bank. If the situation would allow, he would be a traveler, meaning that he would be frequently visiting Jordan, Peru, and Mexico to work with the water utilities in these countries to reduce climate gases and greenhouse gases, and by this, of course, dealing with the climate mitigation topic in the water sector. So Martin will give you a quick introduction into that report, why that report, and so Martin, I'd like to hand over to you. The floor is yours.
Yes, thank you very much, Dieter, for that nice introduction. So I'm going to give you a bit of background information first. What was the background and environment in which we did this report, and also why we decided to do it. So let me start with some background information. I hope you can all see my presentation, but nobody is complaining, so I assume that it's okay. I'm starting with this quote. For those who just also assisted the keynote, there is also another important quote which says, if climate change is a shark, water is its teeth. Here is another quote which I think is good and was often repeated. It says, if mitigation is about energy, adaptation is about water. This came up at a time when it became obvious that if we want to deal with climate change, we must do more than only reduce emissions. We have no choice but to reduce emissions if we want to control the planet and the climate. But still, even if we decarbonize completely, we still will have impact of climate change, and we will have to deal with them. And this was, I think, for the first time recognized at a broad level through the Copenhagen Agreement in 2009. So there was a lot of expectations maybe from water people and from other sectors that this is a big new topic, adaptation to climate change, and that water might play a big part in it. And I can understand it. Of course, if we deal with climate change impacts, most of them go through water. And we will, action in the water sector is really key and important to deal with these challenges. On the other hand, I liked what Nigel just said about being maybe sometimes too passionate about the sector where you work. And so us water people, sometimes it seems that we don't make the extra effort to really target climate resilience, and that we don't change too much. So I think a lesson learned of the last years is that we have to be specific. A lot of the things we do contributes to climate change, climate resilience, and it's important to always explain why and how this is the case. And that's one part of the background why we did this report. Let me just share these figures with you at the global level. We must be aware that water is the biggest sector for public adaptation finance internationally. At least it was the case in 2017-18. You can see that if you compare it to the figures before, it's actually decreasing a bit, and it's more balanced with the other sectors. So other sectors are catching up. I'm just sharing this with you because I assume that many of you are part of the water community, and we must always know that when we talk to people, we are actually already doing a big share of the adaptation action on the ground. This is the other side. It's mitigation of greenhouse gases. And you can see that water is much smaller here in public mitigation finance. We are already doing a lot, for instance, helping urban utilities with energy efficiency or climate renewable energy or low greenhouse gases, wastewater management. But we might have things to add and to do more. But I don't want to say what the next presenters will share with you. All right, why did we do this report? If there are already so many good and comprehensive reports, for example, the one you see on the right side in the foreground, which is from this year, and it's very good and includes the latest information on water and climate change, the World Water Development Report 2020. I asked myself this question many times in the last month. Why are we doing this report? I assume this presentation is moving for you because I'm getting a message. Maybe you have to go back to presenters mode if you can't see it moving. But I'm okay. I'm on slide 5 right now. Why did we do this report? What were the objectives? Objective 1 was we want to help water people, water decision makers and practitioners, even water scientists, with finding an answer to climate change, to climate resilience, and to reduction of greenhouse gases through a water answer, through a water signature answer. And we thought we must do this by providing a good and solid scientific basis. And that's a big first part of the report. It builds on an analysis on climate and water interactions, both adaptation and mitigation. And this is done by the Potsdam Institute of Climate Impact Research. It was very important for us to involve very strong climate expertise and hydrology expertise so that we have a good outcome here. And then the next 2 bullets, they happen on the ground of this scientific basis. This was done by Adelphi.
Yeah.
I think somebody is talking.
Please mute your microphone if you're not presenting. So in this case, everybody else except Martin should mute the microphone. Thank you.
Thank you. So on the basis of this scientific state of the art, we need, on one hand, political key messages for explaining not only water is important for climate change, but we want to help our community with explaining water is important for reaching this specific climate change goals, because So that's one objective, and the other one is to also help actors on the ground to not only react to the changing guidelines and rules and only to make their existing programs climate ready, but to come up with a water answer, to use the experience from water for engaging in the broader climate resilience and climate mitigation discussion across sectors. Also in nexus approaches, just come up with a water-specific contribution to climate action or for climate action. And that's actually what we mean with the title, which my colleague Marcel Servos has invented, who will talk later on. That's what we mean. We mean stop floating, stop following guidelines and not changing much of your programs beyond that. Start swimming, start being proactive, start getting own water signature action for reaching the climate goals. All right, and this is the translation of these goals into the report. So for the first part, as I said, the Potsdam Institute for Climate Impact Research did analysis and work, and we find the answers in chapters 2 to 5, and Tobias will present on that right after me. And for the substantiated political key messages and for identifying specific water action, Adelphi did chapter 6, which is on adaptation, chapter 7, which is on mitigation, and chapter 8, which is on interlinkages among policy goals, SDGs, disaster risk management, and climate goals. All right, that's it from my side. It was really a lot of work the last months and even years. Thank you also to all those who contributed to review of the report, and I'm really glad we finished and we got it launched today. And yeah, that's it. I leave it up to you after this event if we reached the objectives which I described right now. Thank you very much.
Thank you very much, Martin, for that setting the scene. So I think a very clear call for not only standardized water action, but actually have a clear focus on the interlinkages and start swimming and stop the floating. Maybe, as also I think Nigel said in his keynote, focusing too much on the own sector is not very always helpful actually to really have meaningful impact. So therefore, I think that's why you set the scene, I think, right nicely, and why this report is being produced. Now, let's come to the report itself, the content. I'd like to welcome Tobias Pilz. He is a hydrologist of Potsdam Institute for Climate Impact Research in Berlin, PIK. He is with PIK since 2019 at the Group of Hydroclimatic Risks, and he's an expert when it comes to hydrological model development and the analysis of hydrological extremes and climate change impacts in the water sector. So obviously he has been instrumental in developing that report, and I'm very happy to have Tobias with us today to give you an insight into the physical perspective of the report. So Tobias, the floor is yours.
Yes, thank you very much for the kind introduction. And I try to get my presentation running, and I hope you can see it now. So I'm not sure in which window, but yeah, I just assume that you can see it, otherwise you can complain. Now let me first introduce you to the global water cycle, which is also a big part in the report. And as you can see here, we have several storages, big storages, the ocean, the ice caps, and also groundwater and rivers and lakes. But when you look at the numbers, you can see how big these storages are. And there you can see that the ocean forms up the by far biggest share of water on Earth, which is about 79%. So about only 3% of Earth's water is actually fresh water that can somehow be directly consumed or used by humans. And of this 3%, about 2/3 is stored in ice caps and glaciers, so not directly available, and about 1/3 in groundwater, which is more or less indirectly available, and only about 0.4% of the 3% of freshwater is stored at the surface in lakes, rivers, and swamps, which is more readily available, but you can already see that only a small part of the water on Earth is accessible and consumable by humans. And the climate change has a large impact on that water cycle. So as you probably know, greenhouse gas emissions are increasing and have led so far to a temperature rise of about 1% on a global average. And because of that, we have more energy in the system, and evapotranspiration has increased by about 7%. But warmer air can contain more water, and therefore the precipitation has not increased so much, about 1 to 3%. It's hard to quantify that. But yeah, precipitation has not increased so much as evapotranspiration. And at the same time, less water is stored in snow and ice because of snow and ice melt. And the impact on groundwater storage, we don't really know. There are some studies, but it's really uncertain to what extent climate change affects groundwater storage. But on the other hand, it's also known that it has negative effects on water quality because of rising temperatures and other associated effects like algae growth and eutrophication of lakes, for instance. Now, to really quantify climate change impacts on water resources, we can use several indicators. These indicators can be broadly classified. So we have meteorological indicators like rainfall over a specific period of time, like rainfall per year or per month. The same with evapotranspiration, potential evapotranspiration, which is the evapotranspiration under assumption of unlimited water availability, which is an indicator of energy in the system. And then actual evapotranspiration, an indicator of plant productivity, because much of it is transpiration by plants. Then we have hydrological indicators like runoff. Local runoff is basically precipitation minus actual evapotranspiration over a certain surface. So it is the amount of water which is then just distributed either over the surface or subsurface. So part of it forms groundwater recharge, an important indicator because groundwater recharge determines how much groundwater is actually exploitable in a sustainable manner by humans. As such, groundwater recharge should always be higher than groundwater abstraction in order to ensure sustainable use of groundwater resources. Then we have river discharge, an important indicator for surface water, because it determines how much water is available at the surface. And further indicators relating to hydrological extremes, for instance, the return period of a certain river discharge, determining the severity of a flood event, for instance, or the inverse of it, the frequency of exceedance, like how many times a certain flood level is exceeded, like once per 30 years or once per 100 years, which would be an extreme event. And there are indicators for water quality, like water temperature, which I've mentioned earlier, and also the concentration of algae or nutrients like nitrogen or phosphorus and others. But as a modeler, or how does it work that we quantify such changes in the water cycle and quantify these indicators? And as modelers, we usually start with global climate models. So we feed greenhouse gas emissions into the climate wallet and translate these into a temperature change projection and also rainfall projection. But on a global scale, these estimates are rather coarse and rough. So at the local scale, when we use an impact model, climate change impact model, for instance, a hydrological model in hydrology, the model are running on a much smaller scale, which much more detailed, but there's a gap between the scales. And this gap between the global climate models at the one hand and the hydrological models at the other hand, we can bridge either via regional climate models or also via statistical relationships. This is also what is called downscaling. And then the regional climate signal is compared with observations. And when there's a bias, this bias can be accounted for in order to have adequate input to our hydrological models. And one important project where this has been done and whose results are also used for our report is a so-called ISIMIT project, which stands for Intersectoral Impact Model Intercomparison Project. So we have different sectors here, like water, forest, and agriculture. In our report, we also were focusing on water. And for these different sectors, we use different models, so different climate models and also different hydrological models. And we consider different emission scenarios, which are usually referred to as representative concentration pathways in the latest IPCC report. And for our water and climate report, we use emission scenarios RCP 2.6, which is a low and very optimistic emission scenario, and the 8.5, which is a business as usual high emission scenario to somehow estimate this band between the lowest what is possible and the highest likely emissions until the end of the 21st century. Yeah, and then within this project, there was a defined protocol. So the different modular groups had to adhere to these to this protocol in order to make the model results as best comparable as it is possible. But model results are always associated with certain uncertainties, starting with the greenhouse gas emissions, because we simply don't know how the future conditions will evolve and how future greenhouse gas emissions will evolve. So there's a high uncertainty associated with that type of or a high degree uncertainty, so to say. Then we have the global climate models. We can use different global climate models, but each model, of course, has a specific uncertainty, and the same also is the case for the hydrological models. Usually the global climate model uncertainty is higher than for hydrological models, but as you can see here in the specific example, where some colleagues tried to quantify that, and they found that it looks different in different regions. For instance, here in blue, we have regions where GCM uncertainty dominates, which is especially the case for tropical regions, but also for higher latitudes like parts of Siberia, whereas in the drier regions and subtropical regions, hydrological model uncertainty is usually the largest source of uncertainty. And in the end, we can try to account for these uncertainties and reduce these uncertainties via bias.
Tobias, you're muted. I don't know if you hit the button somewhere. Just check check your microphone.
I think I was muted by somebody, because I think I was not muted the whole time, or no?
Just the last 15 seconds.
All right. Yeah, I don't know what happened. Okay, but you can see now my presentation again, right? And you can hear me, hopefully.
Yes.
Very well. So what I was about to say is some uncertainties will always remain, and we cannot account for all uncertainties in the end, even with perfect models or almost perfect models. Now let me show you some example results. Here we see projections of droughts until the end of the century in comparison to a historical reference period. And you can see here the change of the number of days under hydrological drought conditions under the high emission scenario RCP 8.5. And you can see that the picture is different for different regions. So we even have some regions like here in Eastern Africa, where the number of days under drought conditions is projected to decrease, the same as in parts of Siberia and northern Canada, but in most regions it's projected to increase, especially in the Mediterranean areas and also parts of, for instance, South America or Southern Australia. And other studies show that this can increase the share of people suffering under from water scarcity by about 40% when assuming a global warming of 2 degrees above present conditions. And what can be done against it? Of course, groundwater exploitation might be a good a chance to reduce water scarcity, but on the other hand, as I said, it must be sustainable. For instance, that the groundwater recharge should always be greater than the groundwater depletion. And on the other hand, in some regions, it is just not possible to use groundwater. So in the end, reducing greenhouse gas emissions is always the best idea because this would substantially decrease future water scarcity, as many studies have shown. The same we can do for floods. Here you see flood projections of a flood that occurs on average every 30 years. So this is kind of a moderate flood. So already associated with some damages, but still more or less moderate. Again, under RCP 8.5, towards the end of the 21st century in comparison to a reference period of the 20th century. And you can see that the picture here, as for droughts, is quite different in different regions of the world. For instance, we have a decrease of the flood level in parts of Eastern Europe because snow melt would decrease, whereas in most parts of the world you can see a strong decrease of such flood levels, especially, for instance, in northern India in the Ganges River Basin, but also in Siberia and other regions. And this flood risk can be reduced by strong adaptation efforts. For instance, by higher dams and other things. And hotspots here have been identified as being in the United States, Central Europe, Northeastern Western Africa, and large parts also of India and Indonesia, because here we have a high population density and therefore a high flood risk, because the flood would affect many people, in contrast, for instance, to many regions in Siberia. But you have seen that climate change impacts are different over the globe. That's why in the report we were focusing on 6 diverse regions located in different regions over the world. And here we have also identified quite different regional impacts of climate change on the water sector. For instance, some regions will become wetter, also associated with higher flood risk, like the Blue Nile and also the Ganges Basin, while other regions, it's completely the opposite. They will become drier with a much higher drought risk, like in the Tagus River or in Southern Africa, the Limpopo River. And in other basins, the variability will change. For instance, the Upper Niger, we have identified higher drought risk, higher flood risk, but also longer period of pronounced wet periods at the one end and pronounced dry periods at the other hand. Now we can look at details. Here we see the temperature projections for different scenarios, and you can see the higher the greenhouse gas emissions, here the red curve, the higher the temperature signal or what is projected. And this is quite clear. The uncertainty is rather low, so temperature is not a problem for modelers. And you can also see that temperature decreases mostly evenly over the whole year, with some exceptions for us. For example, for the Tagus region, where temperature is projected to increase more during summer than during winter. Now, when we have a look at rainfall changes, it's not that straightforward. So there are high uncertainties. You can see it here. but in the end, we usually can see some pattern. Like, as I said, the Tagus, the higher the greenhouse gas emissions, the more likely it is that the region will become drier, the higher the drought risk. Whereas in other regions, good example here is the Ganges Basin, where the seasons could shift. For instance, we have later onset of rainfall, but therefore the rainfall season or the rainy season might extend over a longer period, and also the water availability as a whole could increase. And this signal can also be translated into the discharge signal. But this is again even more uncertain because discharge modeling is just more complicated, for instance, or even more complicated. So we have increasing uncertainty from temperature over rainfall to discharge. Now, to summarize, we have seen that even small changes in climate can have significant impacts on the water cycle, but also on extreme events such as floods and droughts. And it has to be considered that we have to have a closer look at the regional and local levels, because the global signal is not a good indicator for local decisions, because locally the impacts can be very different in different regions. And in some regions, it might be even unclear how climate change will impact because of the large uncertainty associated with the modeling. So the next steps is, which is especially important, we have to maintain the hydrometeorological monitoring network. So we need rainfall stations and discharge stations. At the moment, the number is decreasing, but the number should increase again, because even though we have now remote sensing data available, remote sensing data have such a low quality at the moment that we need more stations. Because the station data have a higher quality, higher reliability, and when we combine it with modern methods of data fusion, for instance, we can make use of both advantages, like a higher quality of the station measurements and a higher resolution, spatial and temporal resolution of remote sensing data. And we also still, you have seen the projections are uncertain. We need to improve the models, for instance, by enhanced coupling of climate and hydrology in the models, which is a problem so far. We need to better account for groundwater, because this is very difficult. And also, there are hardly any climate change impact studies on water quality, especially on global or, let's say, these continental scales. So there remain many things to do. And with this, I want to thank you for your attention and then hand over to Annika Kramer from Adelphi.
Okay, thank you very much, Tobias, for that introduction and that presentation on the physical science perspective of the report. You have mentioned a few times the uncertainties, and now in the next step, in the next presentation, Annika Kramer from Adelphi will focus on these uncertainties and how to deal with these uncertainties and how to deal with entry points which are coming out of that report. So Annika Kramer coordinates the water sector at Adelphi, focusing on international cooperation, resource governance, vulnerability and adaptation to climate change. She has vast experience in political analysis, and she was, of course, a very important part of developing that report. So I'm very happy to welcome her today in that session. Annika, the floor is yours for the political side of the report.
Thank you very much. Dieter, can you please confirm that you see my presentation properly?
I can't see it yet.
You see, okay, let me, can you see it now?
No.
Okay, interesting.
I think you might be sharing the window instead of sharing the presentation.
So what you see my window?
Yes, we see your Teams chat window.
Okay, interesting. It worked when we tested it, but let me stop the presentation, the sharing, and then share again.
Okay, maybe I can use the time just for a quick announcement. So if you have any questions on the presentations and what we have seen until now, we'll need to see if we have time at the end. If we don't have time to discuss these, of course, very welcome to join the interaction in the event app on the giz.plus.net, where you can then post your questions and then we can start a discussion. But now I see the presentation is up. Annika, now the floor is yours.
Okay, thank you. Glad to see it. Yeah, thanks again for the introduction and also for organizing this launching event of our report, which has been a great cooperative work between GIZ, PIK, and ourselves, Adelphi. So after we have just heard on the physical perspective on water and climate change, I would like now to present some selected key messages on how resilient water management can contribute to climate change action and policy. As Martin has mentioned, our report has two parts, and I'm presenting the second part of the report. We have clustered the key messages in this part in three topic clusters. One focusing on the role of water in increasing climate resilience, then the role of water in contributing to climate change mitigation, and the role of water in bridging international and climate development goals. Starting with the role that water can play for climate resilience, one of the first key messages, of course, is that appropriate water management is key to increased climate resilience across many sectors and also society at large. And this message may well be very obvious and well acknowledged within the water community, but it may still not well be recognized in climate policy and adaptation plans of other sectors. So as has already been said, we have to put more effort in substantiating this message with evidence. Okay, so where did I stop? Indeed, the water sector has has dealt with uncertainty and climate variability for long and has developed solutions to adapt to limited water resources and variability, be it through water reuse, desalination, or storage concepts. But up to now, those measures have often been based on the assumption that climate variability would just continue as over the past 100 years or so. And as we have just learned from Tobias, this will not be the case. We know that climate change will increase climate variability and extremes, and therefore the water sector needs to adapt new approaches to assessing climate risks and vulnerabilities, and factoring in the multiple uncertainties that come in not only based on climate-related issues, but also socio-economic uncertainties. There have been several concepts being developed for this. One of the important last or recent ones, the CRIDA, the Climate Risk Informed Decision Analysis, developed by UNESCO and other actors, that can be applied. Based on such an risk assessment, resilient solutions for water-related or for climate-resilient water management can be designed, and those risk assessments can also serve as a basis to then later on demonstrate the contributions that sound water management can make to reducing climate risks and vulnerabilities. So one of the issues that Nigel mentioned in the morning, we need to demonstrate these effects more in a more convincing way. So such risk assessment can play an important role here. Risk assessment, however, doesn't reduce all the uncertainties, and so in face of those remaining uncertainties and a clear assessment of the risks, then robust and flexible solutions need to be designed. Robust solutions are those that deliver their purposes under different future climate and socioeconomic scenarios, or flexible solutions that can be adapted to changing conditions. Also, in face of uncertainty, solutions that create multiple co-benefits in water resources management. These are often in the realm of biodiversity, mitigation, but also for improved livelihoods. So solutions, we have earlier often called them no-regret solutions, but we decided to rather call them multiple co-benefit solutions, also to point out to the fact that those of course also come at some costs, but by delivering multiple co-benefits, they can contribute to increasing resilience. One way of developing such flexible but still structured adaptation plans are adaptation pathways that foresee a clear a row of measures that can be taken depending on how the future develops. This needs to come together with an adaptive governance approach and regular review of the situations, learning from what has been done in the past and what has been effective, and then looking forward to the future and changing the path. One way to one approach that has been shown to be specifically effective in providing robust and flexible solutions are nature-based solutions and ecosystem-based adaptation, because those usually can adapt to changing conditions and also are very effective in providing the multiple benefits that I have just mentioned. Nature-based solutions can also play an important role, for example, as part of more diverse and flexible flood risk management, such as in floodplains, combined sometimes with also grey infrastructure, but also physical storage systems. And in fact, the crucial role that improved storage capacity plays for climate adaptation is one of the key messages that I would like to highlight in this presentation that we also addressed in the report. Resilient water storage buffers the impact of climate change, variability, and extremes, and can also replace the natural storage that is lost through climate change, such as in glaciers and snow masses. Integrated storage concepts need to be developed that combine different ways of storage, including natural storage, but also green and grey infrastructure, such as dam or artificial aquifer recharge. These different components of an integrated storage systems all have their different pros and cons. For example, aquifers provide long-term storage and without any evaporation losses, but of course recharging, the managed recharge is sometimes energy efficient and is also comparatively slow as compared to others. Yeah, and like this, we have in our report, we have identified the different disadvantages and advantages of the various storage components, and highlighted the fact that if those are combined in an intelligent manner, indeed very improved storage can be provided for resilient water resource management. Last but not least, increasing climate resilience through water needs sound governance. It has also already been mentioned before. Adaptation in the water sector will also need sometimes difficult decisions affecting other sectors, for example, as in land use change, if floodplains are to be restored, wetlands, etc. So there's a need for improved coordination and integration of sectoral concepts and adaptation policies, also applying a nexus approach. Then again, water management often takes place at the local level, whereas adaptation strategies and then are developed also at national level, and we have the international governance level as well being of relevance here. So we need to make sure that those different levels are coordinated. And last but not least, especially in water management, we often have to deal with transboundary issues as rivers cross borders. And here there's also an opportunity to build on the existing experience on transboundary water cooperation to develop this further actually into transboundary resilience management. Building on the existing structures for cooperation, but also, on the other hand, using climate change as a topic that can more easily be agreed on besides the allocation of water resources.
Annika, you've got 3 minutes left, please.
Okay, thank you. So based on this, we identified some selected entry points, some next steps that should be taken by the water community. First one is to mainstream economic analysis of climate change impacts and integrated risk assessments in public and private sector activities, to promote the integrated and flexible approaches combining green and grey infrastructure and adaptation planning, establish effective governance and coordination mechanisms, including cross-sectoral participatory processes, and also to promote regional initiatives for transboundary climate resilience and integrate better the transboundary perspective into NDCs as well as national adaptation plan processes. Coming quickly to the second very important aspect, the role of climate change mitigation, the role of water for climate change mitigation. We have looked at 3 different main processes. The first one being energy-intensive processes for water supply and sanitation. Then the decomposition of organic material and nutrients in surface water and also paddy fields that is associated with discharge of untreated wastewater and unsustainable fertilizer use. And last but not least, the sequestration and storage of greenhouse gases in ecosystems such as peatlands. For the report, we have developed this graphic to illustrate those different sources of greenhouse gases related to water, and have identified different strategies on how those greenhouse gas emissions can be reduced. So looking at the water supply and sanitation sector, there's great potential to increase energy efficiency and also to recover energy from wastewater and sludges. Then the outgassing of greenhouse gases from surface water bodies and dams as well can be reduced by improving wastewater management, reducing discharge of poorly and untreated wastewater and also sludge into the environment, not only water but also dump sites. And looking at rice fields, there's different ways of how the irrigation, flood irrigation patterns can be adapted in order to reduce the emission of greenhouse gases. So based on that, again, we have identified some entry points for next steps. So the first one being encourage energy efficiency and activities in water and wastewater utilities, by providing tools for, on the one hand, assessing potential and cost potential and also the costs of such efforts, and also by providing guidance on incentivizing policy frameworks. Then to further increase the coverage of wastewater to improve human ecosystem health and thus reduce greenhouse gas emissions. then on the fact of knowledge and data on the greenhouse gas emissions besides CO2, but also looking at methane and nitrous oxide, there's the need to gather more data on emissions related to the water sector here, and also to inventory them, such as, for example, the emissions from dam reservoirs, etc. Then on the potential for greenhouse gases from wetlands, that will be presented by Gina Levette in the next in one of the next presentations, as we have just heard. And one important message on the role of water for mitigation is also that we should also always remember that there are synergies between adaptation and mitigation in the water sector. For example, if we look at restoring wetlands, those will have adaptation effects as they improve storage of water, but also mitigation effect as greenhouse gas emissions from degrading wetlands are being reduced. The same refers to demand management measures of water demand management, which clearly contribute to adaptation to reduced water availability, but will also bring about mitigation effects by reducing energy need for supply and treatment.
Okay, Annika, 1 minute.
1 minute to on the last important aspect that we increase, and I'll be quick here. Water is in an ideal position to bridge the international development and climate agendas through those co-benefits that I have mentioned. And those synergies should be better exploited in order to use the existing financial and other resources more efficiently, and also, of course, to avoid trade-offs between the various goals related to climate mitigation, adaptation, and disaster risk reduction. So the entry points identified here is to start from the ongoing NAP processes to ensure that water-related adaptation are considered here, then to provide guidance and checklist on how water adaptation mitigation issues can be addressed in climate plans and strategies, to promote the inclusion of water-related greenhouse gas mitigation in NDCs, including from ecosystem-based mitigation activities, and Gina will focus more on that. And last but not least, promote a holistic approach to address water, climate, and development interlinkages in the related international frameworks. With that, I thank you for your attention and sorry for the hiccups in the presentation.
Okay, thank you very much, Annika. We know that sometimes, even if everything's readily prepared, technical problems can come up. So thank you for that link towards the political perspective of the report. Now I quickly hand over to Marcel, an advisor within my team of the sector program on water policy. He started at GIZ Fiji and has been working since then on water and climate issues since 2018 within the program as a political advisor to the BMZ. So Marcel, I'll hand over to you to quickly show the launch of the website.
Yes, thank you very much, Dieter. Yes, together with Martin, I oversee the process from the GIZ side. And as you can imagine, such a comprehensive report and publication demands quite some endurance. So I'm pretty sure that I'm not the only person today that is very proud that we reached the finish line. So therefore, I'm also very happy that I'm in the honorable position today to cut a virtual ribbon and officially launch our homepage. Let me share my screen there. You should see now my internet browser. This site is the new home of our report. You can reach it via the domain start-swimming.org. If you type in start-swimming.org, you will reach this site where you can see the download publication. We have, so my initial idea was to go through this in a little more detail. Now that we are quite late, I just invite you to do it yourself. You will see that we actually actually found a structure for the homepage that is a little bit, let's say, it's a little bit like the one you find with IPCC, the ones who already know the climate reports by them. We think it's very nice to have the structure by different chapters. So what you can do is you have the choice to either report the whole report, or you can just go through the different chapters and just like look it up one by one.
I actually had tried to call you before I submitted the application.
Someone has tried to call someone before.
Sorry, can you please mute your microphone if you're not presenting? Thank you.
Yes. So what you can see here are the different chapters. So the structure is pretty much the same that we just have heard. We have a political and a physical science part. Yes, we also stress that water is very important for adaptation, but also for mitigation. Therefore, we have also dedicated a whole chapter on the issue. In this regard, apart from providing a broad knowledge base for water and climate practitioners, one of the main motivations behind our report has also been to spur some discussion on climate action through water. And therefore, we are not only very happy to launch our own report together with PIK and Adelphi today, but we also highly appreciate another publication, Dieter has mentioned it already briefly, that picks up one of the issues raised within our report, namely the vast mitigation potential of freshwater wetlands. And so we would like to also congratulate the Alliance for Global Water Adaptation, in short AGWA, and Wetlands International for the publication of their wetlands report, which has been supported by GIZ Water Policy on behalf of the German Ministry for Economic Cooperation and Development. So given the time, I just invite you again to just explore yourself our homepage. And we're very proud that it's from now on officially launched. Please share and spread the domain and the report. So I just quickly hand over to Dieter straight away to go further and give Gina the chance to talk about their report.
Yes, thank you very much, Marcel, for that quick introduction, and thanks also for the link to the next presentation by Gina Lovett on the launch of the Wetlands report. Gina is the Global Head of Communications and Advocacy of Wetlands International and is a sustainability communication specialist and strategist with more than a decade experience. So Gina, I'll hand over to you. As I said, that's a bonus. That's the second launch of the report, although only one has been announced. So Gina, to you, please.
Thank you very much, Dieter and Marcel. Just to check, can everybody hear me and see my presentation? No complaints. OK, I just want to build on a couple of points that have been made today. We've already heard how water-based ecosystems are really important to build resilience, and they provide a buffer against floods and droughts, for example. They really help us deal with the uncertainty of climate change. But unfortunately, at the moment, we're seeing the opposite of this. So we're seeing that ecosystems are really losing water and they're becoming increasingly vulnerable. And this picture here is the Paraná Delta in Argentina, which is currently experiencing unprecedented fires. This is really unusual because this is a wetland. It's part of one of the world's biggest wetlands of the Pantanal. And this area is being drained of water to expand agriculture, to make way for the city. And we're seeing this as a pattern of land use that's repeating across the globe. So we're seeing fires in Siberian mires. We've even seen them in the Netherlands this year. So this is increasing vulnerability in the face of climate change, but it's also creating a huge source of greenhouse gas emissions. And I just want to take you through some of the land use scenarios that are really creating a source of greenhouse gas emissions. So if we home in on peatlands, and Annika mentioned already that peatlands are a particularly big source of carbon. They're big carbon stores, and it's quite a special type of soil. So it's waterlogged, it's partially decayed matter that has accumulated over thousands of years. And in ordinary circumstances, when this peatland is intact, the water table is held at the same level of the soil, and it locks the carbon away, a little bit like a water vault, if you like. But what we're seeing is with many land use scenarios across the globe, that this is actually the water table is dropping, so many areas are being drained. I'll just point to one instance there of drainage with ditches, and we see this in areas across the tropics, for example, when land is cleared to cultivate palm oil. So you can see that methane is released, carbon dioxide, nitrous oxide, and you also get a release of dissolved organic carbon into the water body. So that impacts the ability of that water body to also absorb carbon dioxide. The second instance that I'd like to point out, which is also very critical, is the instance of land degradation, peatland degradation in the condition of permafrost. We know that these areas are vulnerable to the impacts of climate change, but we're seeing industrial land use, which is often quite reckless because these areas are sparsely populated. And again, the release of carbon emissions and greenhouse gases is quite significant. So you could quickly see at a landscape scale, there are multiple impacts of greenhouse gases being released, and it quickly adds up. So you're probably thinking, what can we do about all of this? Well, there are two pieces of knowledge that an analysis that I want to share with you today that's featured in our report. The first one is looking at the percentage of peatland cover around the world and those countries with really high peatland concentrations within their territories. So we see here that the Arctic countries have massive stores, but there's also been recent discoveries across Central Africa and Southeast Asia. The key message here is that no drainage is actually safe with these carbon stores. They really need to be safeguarded. And by way of illustration, the concentration or the carbon that's stored in those Arctic countries is the equivalent to twice the amount that is currently held in the atmosphere. So if that's released, it's really catastrophic. Second piece of information that I want to get across is in relation to drained organic soils. And these are peatlands that have already been degraded. And we see here that the top three emitters have an outsized impact. So they're accounting for 70% of emissions. And that really highlights that there's a decisive course of action that we can follow. And if we restore our degraded peatlands, then we can really make a significant impact on our carbon emissions. So just to point you also towards this report, it's called Locking Carbon in Wetlands. The main focus of this is really to highlight the value of wetlands in helping countries achieve their climate mitigation targets, but also at the same time unlocking a whole host of co-benefits, supporting biodiversity, boosting resilience, and being a type of inclusive climate action for communities, supporting livelihoods. So if you are interested, I'd invite you to check out the link there, wetlands.org/publications /locking carbon in wetlands. We haven't got time for questions, I know that, but if anybody does want to, if they have a query, if you can find my contact on that link there. And just to end by saying a big thank you to all the colleagues at AGWA, at GIZ and Wetlands International. Thank you.
Thank you very much, Gina, for that quick presentation, and I'm really fascinated about that topic of ecosystem-based mitigation. Thank you very much for that presentation, and so we've got now two fascinating and interesting reads for you, two reports now just being launched. Without much further ado, I'd like to hand over to Mike Enscott for the closing for that session. We are a bit behind time, but Mike is our head of infrastructure section within GIZ sector and global programs. That means he's in charge for energy, water and mobility. So he will give a quick some closing remarks for that session where two reports have been launched and where the issue of climate change and water and interlinkages have been closely highlighted. Mike, I hand over to you.
Dieter, thank you very much for this introduction. Good to see some of you again, because some of you were listening to me this morning in the opening remarks. Not much left for me to say in this session. I would really like to thank all the speakers for your valuable contributions this morning in this the context of the launch of this important report. And I think with today's publication of the report, we have really made a big step forward in linking the water resource management issues with its relevance for climate action. And you know, for us as GIZ, it's always of utmost importance to ground our work and our output on a solid evidence base. And so it's but also based on our long-standing experience in working with our partners on the ground. And certainly this aspiration has also been a major driver behind the commissioning of this comprehensive report, which we have done on behalf of the BMZ, the German Ministry. And in consequence, we are really more than happy about the publication and the launch of the report today, as well as the drafting process behind it, which allowed us really to team up with several research institutions and water climate practitioners around the globe. So in the first place, let me thank again the Potsdam Institute for climate impact research, as well as adelphi. The drafting would not have been possible without our strong collaboration and the collaboration between the two of you, as well as the GIZ's water policy program. But let us not forget that there's still a lot of work to be done, and several challenges still lie ahead of us when it comes to promoting the value and opportunities of water-related activities for climate adaptation and mitigation. Today's contribution, I feel, have already offered a set of convincing approaches and water solutions to address some of these challenges that still lie ahead. Flexible water storage systems that help to enhance the climate resilience of people and ecosystems by buffering extreme droughts or floods. It's just one such example. Another example is the broad potential of transboundary resilience management, since rivers and lakes, like climate change in general, do not care about national borders. So to sum up, we are convinced that it's time for the water sector to build on its own strengths while taking even more responsibility in shaping the future of climate action. Now it's up to us, so let's stop floating and start to swim. And I thank you for your attention and for your contributions.
Okay, thank you very much.
Dieter, you are muted.
Okay. Well, I'll try.
No, you're muted again.
Okay, now I'm not muted anymore.
I can hear you.
Okay, that sounds like it should be. Okay, thank you very much to everyone. And thank you very much, Mike, for your closing remarks. Thank you very much to all of you who participated in this session. And of course, a big thank you to the team who prepared the session, who developed the report and the reports, including the wetland report. And of course, a big thank you to the BMZ, who has financially made all this possible. So I don't want to keep you much longer from all the other interesting sessions, which have already started. The next session has already started. So, but I'm very happy to have these reports out now, and I'm very happy to follow your discussions and your questions on the event app. So please, if you have anything to discuss and questions, remarks, please share it with us. We'll be ready to respond. Thank you very much and have a good day and enjoy the rest of the Water and Climate Day.